I today discuss about how we can generate a group in set theory, or what is called a group in the set theory. Uh, so first we have to discuss about, I have already discussed in previous class what is a set. We are taking a set like S and we take a binary operation. Binary operation means an operation or any mapping, any relation which is solely defined on the set is. So if we take both this, a set and a binary operation which is fully defined on this set, both together, which has to be has to be satisfied by four properties. First is closure property. Second is associative property. Third is identity element property. Identity property. And fourth is inverse element property. I'm now discussing what are these properties. Like to take a set S which have some elements E, B, C. Three elements I have taken. So with respect to this operation, binary operation, we'll find out that A binary operation B must belongs to set S. Since A and B both belongs to S, so with respect to the binary operation, with respect to this binary operation, A and B, A binary operation B, this element which we now extra found must belong to S. So this can be, this element with respect to the binary operation must be A or B or C. Now another binary operation B, binary operation C, this also belongs to the set S. So this can be also A or B or C, because or a null set here is. So this binary operation we can generate from these three elements. Any element if we get after binary operation must belong to this set S. So if we take three elements all together, like A, binary operation B, binary operation C, and now we find out any element from this binary operation after on three elements, we can find out A or B or C. This also belongs to the set S. If in such under this binary operation star, if all these operations belong to the set S, then we can say that S is closed. This set S is closed under this binary operation star. So if this is satisfied, then we said that S is closed under this binary operation star, and it's this set satisfied closure property. Now another operation, this is operation 1, this is the property 1. Another property is associative property. Associative property means three elements we have find out. So if we take binary operation in this way, a binary operation b under first bracket, uh, binary operation c is equal to a binary operation b uh, under bracket b under b under bracket c. In this way, if we can find out elements that there belongs to an equal sign on those in these two operations, then we can say that AC is associative under the binary composition star, and AC is associative. So if we take A is equal to 1, B is equal to omega, and C is equal to omega square, here these three elements satisfies left side and right side both, because we know that omega cube is equal to 1, and we know that omega is and omega is and omega square and 1 both are the cubic solution of 1 minus 1 minus 1. So this satisfies cubic solution of 1, not minus 1. So omega cube is equal to 1. So left hand side and right hand side can be satisfied. So in this example we can find out, and the binary operation should be multiplication. Here star is the binary operation is multiplication. It can be addition, subtraction, division, any binary operation. So with respect to the multiplication operation, 1 omega square is satisfies associative property, and the set formulated by 1 omega square is associative under multiplication. So also we can find out that this is also closed. So the set now generated by 1 omega square is closed and associative. And identity property is what? What is identity property? So here any element we can find out in the set S. We are taking iota, which is marked by iota. Iota can be A, B or C, any element we don't know, such that A, any element from the set A, and identity element we are taking iota. Iota's value we have to find out with this condition is equal to iota star A, means right hand identity element and left hand identity element equals to, we find out the element E. So so here in this example 1 omega square, we can find out 1 is the identity element. So since we take 1 omega or omega 1 is equal to omega, so omega belongs to set S. 1 is equal to 1 under multiplication operation is equal to 1 belongs to set S, and 1 omega square or omega square omega is equal to 1, because under multiplication this formulate omega cube, So 1 belongs to set yes. So for every element, there is not any identity element. Actually it is this formulate inverse element. Inverse element means this is our identity element 1. Here just one thing has to prove. 1 omega square is equal to omega square under multiplication 1 omega square 1 is equal to omega square. So we are looking that this condition is satisfied by this set 1 omega square with, so one can be said that it is the identity element in the set S under multiplication operation. So we can find out an identity element. So now the question is that what is the inverse element? Here inverse element means other elements in under the binary operation uh, we can find out the identity element. Means under the binary operation to any two elements, left inverse can be or right inverse can be is equal to the identity element. So here omega is the right left left inverse of omega square, and here omega is the right inverse of omega square. Or we can take another way, omega square is the right inverse of omega, and omega square is here left inverse of omega, which is under multiplication, which is equal to the identity element 1. So in this way, all these four conditions if satisfied, then we said that ES under binary operation star generates a group. It forms a group. So this is the conditions required to generate a group. So here I have given an example that S if equals to 3 elements 1 omega square, and we take binary composition multiplication, then S and star forms a group. Any question you can ask me. If you have any question, ask me. Here one property more can be discussed. If actually S formed under any binary operation star a group, then one thing can happen or not happen. This is commutative group, means any group is abelian or not abelian, or commutative or not commutative. So S under binary operation star is abelian or commutative or not, we have to just find out. If commutative, then it is abelian group. Then abelian group. So how we can find out? If we take any two elements from the set S under binary operation A under binary operation star, like A star B, if we find out that it is equal to B under binary operation star A, if this is satisfied, this binary operation can be any operation. So if this is satisfied, then we can say that under this operation the set is commutative, and then this can be abelian. Otherwise it cannot be a abelian group. This is very important for further study in group or ring or field. So you have to know uh, how we can prove that any set is abelian or not. So through commutative operation we can just prove this. So if you like this video, then like, share with your friends. If you have any question, then ask me. Thanks for watching.